Hi, welcome to the Calculus 2 lecture series. And we are in the unit number 3, and we are working on the few more applications of the integrations. And this is our lecture number 13. We talk about the arc length. And this is the second part of the video about the arc lengths here. Okay, let's go to our lecture notes here, see. Okay. All right, so in the video number 1, we talk about the arc length. So here, if you still remember in the video number 1, we talk about how to if you have curves here, then if you want to find the length of the certain curve between the, like the intervals, then what is the formulas for doing that? And we did a little proof, and it's a similar concept like the Riemann-Sum concept, right? So we practice a few problems. So the part 2 in here, we're going to talk about is we're going to define the functions here. So we want to talk about is the arc length functions here. So what is arc length functions here? Okay, so so let's take a look. So we say if I have a continuous continuous differentiable functions here. If I have a continuous differentiable function f of x, and this is what we call, then my x is between the certain intervals here. And then I will let the s of x, okay, be the distance traveled along this function. So along the curve from, you have a starting point is a of f of a, okay, to the x of f of x. So that's why I want to define the general function. So this function is here. So now this function here, the function s of x, that is called the arc length function. Oops, what did I do? Okay, so it's called the arc length functions. Okay, so the reason why I want to do that is so like then instead of every time I just try to integrate and then plug in the upper bound and the lower bound, I can have a function. I will just be able to, wherever you travel from and the to, now I will just be able to plug into the x value, and I will be able to find the distance travel. So basically, this one is telling you here, right? So this is what it means here. And so if this is my functions here, so if this is, let's say here, this is my f of x, right? So like this is my f of x here. So if I have a distance from A to B here, now what is the arc length functions? That means if I start here, I travel, right? Travel along this path, go to here. So this is x here. Then this functions here I call is s of x, right? So let's take a look here. So like we know from the previous, I know the s of x from the arc length formulas. What do we have here? We have is just ax, and then we have this is, we call this 1 plus f prime, right? So remember here we have f prime t, the square, then the square roots, and the dt's here, right? And so also if you can change that, so this is a to the x's here, and then you will have this is y f prime is dy what? Dy dx square, and for the dt here. Right, so here I should dy dt. All right, so now in here, so this is this is what our formula at the beginning of the video 1 we talk about. So now if I take the derivative of both sides here, right? So if we take the derivatives here, so the left hand side, this will be the ds here, right? So the right hand side here by the fundamental theory of the calculus, right? So what is the right hand side? So I have here right hand side, because here this is the x, right? So by the fundamental theory of the calculus, what do the right hand side have? I have is just 1 plus dy dx to the square. All right, so the dx here, right? So you replace the functions here. Now, if you take a look at the ds, if you square that, so what is here you have here? You will have, this is 1 plus, so this one will be 1 plus dy dx to the square. Then this is what dx what square, right? So if you simplify a little bit, this will be dx to the square plus dy to the square here. All right, so basically what is this one tell you? This one tell you is like just like we did it before. So here let's take a look at this one. If if this is my functions here, right? So this is my function, and I'm going to kind of exaggerate a little bit. All right, so in here, if I want to from here to here, right? So if you take a look from here to here, now if you kind of find okay, so I find the ds, right? So what is the ds? ds is the tangent lines here, right? So from here to here, take a look here, okay? Okay, so this distance, remember this distance is delta y, right? And this distance is dx here. And this true distance here from here to here, this is what? This is delta s, correct? But then what is this one? I can use this line. This line is the ds to estimate that. And then like in here, this is delta y, right? So from here to here, what is this one here? This is the dy, right? So so this relation really is kind of like the showing by the Pythagorean series, right? So this is a ds squares equal to dx squared plus dy squares here. Okay, that's what is the meaning for we call this the arc length functions here. Okay, so let's take a look at the problem number 4 here. So the problems here is here, we say for the curve y squared equal to 4x cubed, y greater than 0. And so I want to find the arc length function starting at 0, 0 here, okay? So let's take a look here. So y squared equal to the 4x cubed. So I know y is going to be equal to what? 2x to the 3/2. It's a positive 2 because x is greater than, y is greater than 0. So now I can take a look at the dy dx. So what is the dy dx? Will be 3 to the x what? 1/2. Okay, so now based on this one, I can define my arc length functions. So my arc length function is starting from the 0 to x. Then this is 1 plus dy dx squared, right? So this is 3t 1/2 to the square and the dt. Okay, so now I will have this is 0 x here, and then this will be 1 plus 9t, okay, for the dt. So for this ones here, I can, do a simple, u sub, right? So I can say this one's here, this is u. So this is u, so I will say u is equal to 1 plus 9t, and the du is equal to 9 dt. So that's why du over 9 is equal to dt, right? So now I can simplify the arc length functions here. So this one here, if you integrate, this is 1 over 9. And then this is the square root of the u du. So when t equal to 0, u equal to 1, right? Then when t equal to x, u equal to what? 1 plus 9x, correct? And then you integrate this one, you get 1 over 9. And then this is u to the what? 3/2 and 3/2. All right, then you put the upper bound and the lower bound. Okay, you put the upper bound and the lower bound is 1 plus x. So if you simplify it, then your function going to be 2 over 27, 1 plus 9x to the 3/2 minus 2 to the 27. So that's what we said. This is the arc length function. So you can give me, so you start to travel from the 0, 0. So if in here, let's say, hey, what is the arc length if I travel from the 0, 0 to the 1, 2 here? So from 0, 0 to the 1, 2, that means your x is travel from 0 to the 1s, right? So basically you have a s like what? S of 1s here. So you can just plug into the formula is 1 plus 9 to the 3/2, right? 1 plus 9 to the 3/2, and then minus 2 to the 27. And if you put it into a calculator, you will get a value very close to 2.268. Okay, so it's the same thing like we did before. Right now we just write the arc length into a function form, so you can plug in any points along the functions, right? Okay, let's take a look at the applications here. The problem number 5 will tell you a plane is flying at the altitude 2304 meters, and a suitcase falls from the cargo area. I hope that never happened. And because of the air resistance, so we know the suitcase, the suitcase going down is kind of like a parabolas, right? So they said that the path here is y equal to the 2304 minus x 3/2 over 6. So I want to find the distance traveled along its path. So I want to find this is the path, right? It travels. So I want to see how, what is the path it travels here, all right? Okay, so the first things here, we know the y is equal to the 2304. So let's use the y prime. That is the dy dx. So this will be negative 3/2 times 1 over 6, and this is x to the 1/2. So we give you negative 4 square roots of what? Square roots of the x. And then this is dy dx, right? So now I know that s of x is what? Will just be from 0 to what? To x. And the square roots 1 plus dy dx square. So this will be negative square roots of the t over 4 to the square dt here. And then here, this is 0x. So this is 1 plus 16t dt. And then you can factor the 16 out. 16 would just be 1 over 4. 0x, right? So here, this is what? So 1. This will be 16 plus t et. So here, okay? So then the same way you can do u sub. You can say, okay, here I can do a u sub here. So you will say u is equal to the 16 plus t. Then you can say du dt. Du equal to the dt. Then these things here will simplify. So this will be 1/4, and then this will be u to the 1/2 du's, right? Okay, so when the t equal to 0, u equal to 16. When t equal to x, so this is 16 plus x. Then the same way, this one's here, you will be equal to the 1/4 times the 2/3, right? And this is u to the 3/2. Then this is 16 plus x plus 16. So you will get this is the 6th, and this is a 16 plus x to the 3/2 minus 64. Okay. All right. So now this is the passes here. So now in here, I want to see the whole pass when they hit the ground. Okay. So I need to know what x I need to substitute for that. So in order to find it, so I know that when they hit the ground, that means what? That means y equal to 0, right? So I can set here, so it's 0 is equal to the 2304 minus x to the 3/2 to the 6th, okay? So now you can, so now I can set x to the 3/2 is equal to 1324. You just move the 6 over, then you will get x equal to the 576 here. So now I know that means that the x start with 0, then go all the way to 576, right? So this is the x's, right? Okay, so now I know I put the 576 to my arc length function 576. And then you will get this is 16 plus 576 to the 3/2 minus 64, and this is 6. So I'm going to get approximately is 2389.997. So it's approximately is 2390, right? Okay, and that is the, that is for this video, and we talk about is the arc length functions here. So basically, it's the same idea. We use the same formulas, right? We try to use the 1 plus h prime t square, and then we just find the general form for the arc lengths here. All right, that's it. So then our next video, we're going to talk about how to find the surface area for the river, when you're revolving some curves here. All right, and have a good day. Have a good day, and talk to you later. All right, okay, bye-bye.